In this lesson, we're going to create a simulation layer for our quarter turn valve. So this is necessary because what we'd like is at the end of our sort of development of this project, we'd like to be able to test it, and we really want our valves to be able to accept an open command from our project and then actually open under simulation as if we had the feedback back from the real asset out in the field. And if you do this for all of your assets, instruments, and then the automatic feedback layer for devices such as pumps and valves, then we should be able to completely end-to-end test our entire system with all the program sequences and all that sort of stuff involved as well. And know that when we go to commission the project on site, that any issues that arise can only be either on the way into our project or on the way out of our project. Now, I know that you can't sort of get rid of every single problem that you could have within your project, but having a decent simulation system that is relatively easy to set up, doesn't interact with your project directly, and is scalable, goes a long, long way to making sure that you reduce issues during commissioning. So in our last lesson, we had a look at the input mapping layer, and that is going to be the bit that we expand on. So let's have a look at AVO1. At the moment, AVO1, we have inputs here and outputs here. So let me just make that a little bit bigger. We have open feedback, close feedback, open request, and close request. So what we're looking to do is tie these together in our simulation layer that says when we get an open request, we should receive an open feedback. And by introducing that into our simulation, we can then test things such as our discrepancy alarms saying, or fail to open alarms. We send the request to say open the valve. We don't get the feedback that we are requiring, so we trigger the alarm. But when we're in simulation mode, we have the opportunity to turn that feature on or off and say, under this test, you don't get the feedback. But now that we've tested that and it's working, we can turn the automatic feedback on for this signal. And that means that we will get the appropriate feedback, and that asset will then work as if it was healthy in the real world. And that goes, like I say, a long way to helping you test entire systems. So the first thing to do is to have a look at our simulation folder here, and we have a simulation data block. And in here, we currently have all of the instruments because simulation was already set up for the instruments. And you'll notice that they have a UDT sim analog device. And if I have a look at the definition for that, all that this has got in it is the raw value, because that's the only thing that these instruments require. So that means that our asset devices for simulation for our asset devices will require the open and the close for quarter turn valves, and our modulating valve would require a raw signal because it's a analog device by nature. It would require a raw signal like these ones do. Putting things in their own UDT means, just like the real data, you can't mix simulation data by accident on any interface because it's expecting a particular type. So it's keeping things in that sort of hierarchy approach of this UDT only works with an asset of this type. Even if it's just got the same single variable in it, it makes things very easy then to keep stuff containerized and standardized and in check with each other as you develop more and more objects for your wider libraries. So let's go ahead then and create a PLC type for our quarter turn valve. So you need to be offline, unfortunately, to rename a UDT. I'm not quite sure why it doesn't give you the opportunity at the beginning, but UDT sim and then quarter turn valve. And all that I usually do is I'll open the asset UDT, I'll come to the IO section, and I will pick up everything that is inside the input, because we're only interested in simulating the input. We're interested in reading the output from the asset data. We don't need to simulate the output because that's not what we're trying to do. We're not trying to simulate outputs. We're trying to ensure that the request for the output is driven by our code, and then we react to that request in place of the output leaving the CPU and going off into the field. So paste that into here, and that's it for our simulation of a quarter turn valve. These are the only two signals that we require. So now we need to go and create an instance of this UDT. So if I come back to my simulation data block, and here I will create AV01, and that will be a UDT sim quarter turn valve. And now we have AV01, open feedback and close feedback. So the next step now is to go and have a look at the mapping data, the mapping function rather, and update that to use the simulation data as well. So if I look in my program blocks, mapping layer, mapping blocks, I have my map quarter turn valve. Always a good idea to create these as function blocks, even if right now you don't need the requirement of it being a function block. If you ever want to add a timer or anything like that in, and you've made it as a function, it just becomes a bit of a faff to swap it over. I prefer to just create function blocks for them. It's not really doing any harm, and you just create it as a instance in the mapping layer, and then it's nice and easy to work with. So what we need to do now is in our in-out, we already have the asset data. Underneath, we can have simulation data, and this will be our UDT sim quarter turn valve. And we will also require an input to say, is it in simulation mode or not? So simulation mode, which should be a Boolean. And then what we have here is we need to update our open feedback and our closed feedback to use the simulation system, basically. So, whoops. So if I add an extra contact here, and it's simulation mode. So if simulation mode is not active, then we're going to go down this road. But if simulation mode is active, and we also have in our asset data, because remember we can access the asset data at this point as well, and we have our IO output open request. Then we have our open feedback. Now you could go as far as saying that should be sat this side, however you want to set up your sort of system, and then say if you're in simulation mode and you have an open request, your program should not also be requesting the closed feedback. You know, how you set up your unit testing is sort of up to you, but this is sort of the route that I would go down. And I might also include in here a ton timer as a multi-instance that says sim open delay with a flight time of 5 seconds. So once we send our open request in our program, which we don't have written yet, so the asset management of this is not written yet. We have no way of actually driving this open request right now. But when we do, and we're in simulation mode, we would send the request, which we can read on SCADA, and then or on the HMI, and then after 5 seconds, we would simulate the feedback coming true and saying we have an open signal, which means for those 5 seconds, we can then display things such as the valve traveling. We can start our timers for fail to open alarms, and we can test all of that stuff without it happening instantaneously, because without that timer, as soon as we request, on the next scan, we would say that it's open feedback, and we would miss the opportunity to be able to visually represent the fact that the valve is traveling and the opportunity to test alarms. So if we set our fail to open alarm at 2 seconds, we'd be able to test whether the alarm is actually raised or not. But you wouldn't be able to do that very easily if it was an instantaneous update. So following this approach, you can do exactly the same for the output. Straightforward, copy and paste, and change that to closed. Create that as a multi-instance and drag that up there. And then this one just needs to be changed to close request. And there we have exactly the same thing for the close signal now that we can simulate it. So that's really all we need to do for each of your assets. When it comes to the analog asset for mapping, sorry, I should have clicked on mapping modulating valve. When it comes to doing the modulating valve, exactly the same thing, that when you are in simulation mode, we would want to be driving in our request. So let's go ahead and update that now. So this one would have simulation mode as a Boolean coming in. And we'd have simulation mode on there. And underneath, I like to keep things in the same network because a network is like a container. It makes more sense then that this is the raw feedback position, whether we're in simulation mode or not. So here we would have, instead of IO feedback coming into this, we would have our simulation value, which we haven't created yet. So let's just jump down here, create a new data type, which would be our UDT sim modulating valve. And I know I touched on this earlier, but all this will have is a raw value coming in. And you might ask yourself, well, it's an analog device. You know, a modulating valve has an analog signal coming from it as a feedback mechanism. Why don't we just use the analog device? And the reason for that is in the future, you may change so that your modulating valve also has 2 limit switches or something like that. And you wouldn't then want all of your analog devices to have those limit switches, basically. So trying to containerize things as assets makes a big difference when the unexpected comes along 2 years later. You give yourself a lot more flexibility with your standards. Now that we've created that, we just need to give it an instance, which I have down here, simulation data. So this will be MV02, which would be a UDT sim modulating valve. And now that we've done that, we can then come down to the in-out, add simulation data, UDT sim modulating valve. And then in here, if we then put in here our simulation data raw, and that would go into our feedback. So this is slightly different from our quarter turn valve, because what our quarter turn valve is doing is looking directly at the request. I've split this a little bit because I should have come onto this. I should have done the other one the same way as how I've done this, and then come on to automatic feedback later. But I've gone down this road now, so we'll have to talk about it now. So the way this one's set up is our simulation mode is coming directly from our request in our asset data in the quarter turn valve. So when we ask the valve to open, it will automatically open under simulation mode. Whereas our modulating valve, what we've done so far is say, if you're in simulation mode, I've got these round the wrong way. If you're in simulation mode, once I've updated these, then come from the simulation data raw value and put that into the feedback, exactly the same way as we would do with any of our instruments. However, that's not strictly true because we may want to service the request that our control system is sending the valve. So for that, you would need an additional input into our simulation layer, which I call auto feedback. So if we go back to our quarter turn valve and modulating valve, and we put in a auto feedback, I'll just copy that and put that into the modulating valve as well. And I appreciate this is quite a lot to take in, so I'll summarize this at the end. And then we come back to our modulating valve, update the interface so the simulation data is updated, and then we say if our simulation data auto feedback is turned off, then we send the raw data. Otherwise, if our auto feedback is turned on, then we will send the asset data, which I've just called data in this one, asset data, IO, output, position required. So now what we've done is given an extra layer to our simulation system, and this will become a lot more clearer when we develop the HMI that goes along with this simulation system, because you'll see these buttons on there for things like auto feedback, and then the entry box for simulation data, and things will marry up a lot sort of tidier. But I am going through this from a sort of project flow point of view, so we are starting with the input mapping and therefore the simulation. So if we are in auto feedback mode, then we are looking at the position required from our control system, and that is being passed back as the feedback. And if we're looking at not being in auto feedback mode, then we are typing in on our control HMI, on our simulation HMI, what raw value we'd want to move to. And that opens up the opportunity to introduce errors into our control system, such as we're in auto feedback mode and we have moved to the required position, say 8 milliamps. We turn auto feedback off and type in 4 milliamps or even 3 milliamps outside of range, and we expect our control system to respond correctly. Without having the ability to turn off the automatic feedback, then you are always working with a perfect system, which is not what we want for commissioning and for control purpose testing, basically. So if you want to go down a test-driven development route, we need to be able to test these different tests by turning off auto feedback. So I'm just going to go and update the quarter turn valve as well, just to give you a demonstration of the sort of digital signal side of it as well. So we have simulation mode here. This one would be, I need to update the interface to access the new data. This one would be simulation data, and then auto feedback is not on because we don't want to put in, this one would be on because we are coming from our asset data layer. And then under here, I will put not on. And this would come directly from our simulation data. And then open feedback, which isn't used anywhere else. People who were eagle-eyed when we went through this originally would have picked up what's the point in having the open feedback if we're not going to use it and we're using the asset data anyway. And then that's why, because we need a individual open feedback simulation, because if we're not in auto feedback mode, that's the bit that triggers the open feedback. And we'll just do the same on the closed feedback. So again, in auto feedback and not in auto feedback, we would then use the simulation data closed feedback. And there we go. We now have the option to manually set our feedback systems through this open feedback and closed feedback when we're not in auto feedback mode. But if we are in auto feedback mode, once we've completed all our tests for that asset and we just want it to work, we can then put it into auto feedback and everything will work in accordance to what our project is actually wanting to happen. So when we request the asset to move, it will move via the asset's request itself. So to summarize, what we've done here is we have expanded our mapping layer to include simulation. And if I go to the mapping layer now, which I think I closed, so input mapping layer, we'll see that these blocks want to be updated with the new input requirement, which will be the simulated data, because we haven't done that yet. So if I update the interface, all of these want new data updating. So right click that, update the block call. So if I put in simulation data .av01, that'll satisfy that. And then for a modulating valve, update the block call. This will want simulation data .mv02. And you would need to go and repeat this for all of the blocks, and that should be fine. Just pressing enter on that will clear that fault on this one. So we've only done these two, but what we would need to do is go to our simulation data and create the rest of the valves. So the extra modulating valve and the rest of the quarter turn valves. But in summary, what we're doing is modifying the input mapping layer to include simulation, modifying our mapping blocks to include the testing of that simulation, the auto feedback and the UDTs that are required to house auto feedback and the IO signals simulation, they need to be created, and then everything is just pieced together in this input mapping layer. But we will see this and we will revisit this topic in a few chapters' time when we go through interfacing with the HMI. For this particular lesson, there's quite a lot to take in. If you do have any questions or you need anything explaining, just drop a comment below this video at the bottom. There's a comment section, or jump onto LinkedIn and contact me directly. That's fine. There is definitely bits of this that could be explained better when we have more of the project put together. So we'll see what sort of questions people have. But if anybody has any questions, just ask. And if I need to update or add an additional video underneath this one, then I will do, because it is quite a different way of thinking. But I'm sure once you put this sort of stuff into practice a few times, then you'll see the benefit of doing things this way. And especially when it comes to the simulation stuff. And you don't need to spend loads of money on simulation software for what is realistically quite a simple thing to do yourself once you've got the architecture in place.